Welcome. Let's do arithmetic in Python. These are basic arithmetic and arithmetical operations like addition, subtraction, multiplication, division, modulus, and what have you. So let's take addition for example. If you want to do addition in Python, you use the normal plus sign, just the normal plus sign. So I have, and take note, this must be in code here. We have code, we have markdown, we have raw. So the markdown just gives you your normal writings, but it must be on code. So our normal code here, make sure it's on code so that the calculator will work well, the arithmetic will work. So if it's on markdown, it won't return any answer. Let me give an example. If I have this on markdown now and I put 2 plus 3, 2 plus 3, and I do my shift enter, which is my enter in the Python, it still gives me 2 plus 3. I still get 2 plus 3 because it will not execute anything. It will not execute. It will not calculate anything for you. So, but when I change it to code now, when it's in code and I put my 2 plus 3 and I run it, shift enter, you can see it returns my answer 5. And it's the same thing for subtraction. If I want to subtract now, I have 7, let's say minus 2. I press my shift enter and it's 5. That's the answer. Okay. Let's do multiplication. If you want to multiply now, let me have a number like 5. Then I use this star. This star now. That's shift 8. That's how it is on my system here. So 5, let's say multiply by 10. You see this star signifies your multiplication. So I have shift enter and that is 50. That's for multiplication. If you want to divide, let me say 70 divided by 10. You use this slash. Okay, so 70 divided by 10. I have my slash for division and I do shift enter and I have the answer. The answer returns in decimal. That's a float. Okay, so that is for division. If I want to raise to the power, let's say I want to find the power of something. For example, let's say 2 raised to the power of 3. Raised to the power is double star. I have star star 3. That implies 2 times 2 times 2, not 2 times 3. 2 times 2 times 2. That's 2 raised to the power of 3. And you can see it's 8. So that's raised to the power there. Okay, now supposing I have 10 divided by 3. If I have 10 divided by 3, the answer is 3.33333. And when I just want to get the whole number without a decimal, which is also called the floor function, if I want to get the number without the decimal, I'll go this way, 10, then double slash 3. This will cut off all the decimal. It's not like rounding off. It's not rounding off. It's just taking the floor function. Floor functions simply means the number just before the decimal. So it just does away with the decimal points. Shift enter, you can see this gives me 3. Okay, and there is something called modulus. That's if you want to find the remainder of something. Let's say like 10 divided by 3 now. We know 10 divided by 3 is actually 3 remainder 1. That's if you divide 10 by 3, you actually get 3 and the remainder is 1. If you want to get that remainder, it's called a modulus. So what you are going to do is you say 10, then you put this percentage sign, you put 3. This is 10 module 3, 10 module 3, and the answer is 1. So you can see that gives you only the remainder, and this is called modulus. And you have to note that Python obeys the laws of BODMAS. So you know what BODMAS is already. That is bracket, order, division, multiplication, addition, and subtraction. So what this implies is if I have a number like 2, let's say times 2 raised to the power of 3, then um, let's say plus 1. Now, if you will not obey the law of BODMAS here, you go 2 times 2 and you say it's 4, 4 raised to the power of 3, you say it's 64, then you say plus 1, which is 67, but that's wrong. That's wrong because this will obey the law of BODMAS, and you can see the answer is 17. So what it does is that it doesn't do the multiplication first, it does the power first, which is the order. So because after my bracket, I have order before division and multiplication. So it takes the order, which is 2 raised to the power of 3. So it takes the 2 raised to the power of 3 first of all. And 2 raised to the power of 3, it's 8. So it now does times 2 of that. So you now have 2 multiplied by 8. So it does the order first, multiplication, then before the addition, and you can now see that 16 plus 1 is equal to 17. So this is it. It obeys the law of BODMAS. All these are called base functions. They are called base functions, meaning that they are obtainable even without importing anything. If you want to carry out real mathematical functions, then you will need to import. Now, there is a library called maths. Library are packages. They are like packages containing formulas that have been prepared, and they are kept somewhere, but it's not part of the follow-come packages of the Python. So you have to import it. You import the library. It contains all the formulas you need. It contains all the things you need in this math. So, but it's not there. You have to import it manually. So we have, let's say, import. I want to work on maths now, so I import maths. Just math, no s. So if I want to work on any other thing like logarithm, like sine, like cosine, and this, I will have to import this math. You can import it just as math or import math as m. Now let me import math as m. Now any other thing I want to do, I need to include that m first of all. So for example now, let's say I want to find the logarithm. Let's say I want to find the logarithm. Let me have it m dots. You can't just put log. If you go ahead and just put your log without the m, it's not going to work. Meanwhile, if I just imported as import maths without putting the as m, it means what I'll put here will be maths.log. But since I say as m, the m is now representing the maths. So let me find the logarithm. Okay, you can see we have log to base 10 here. Let's say I'm finding that of 1000. So I shift and enter. You can see log to base 10 of 1000 is actually 3. So that is it. That's how to find this. If I want to find my pi, for example, I can use the m, or I can simply use my maths.pi. Okay, if I just press this and I press my tab, it will give me the remaining. And I just get this, I shift and enter. You can see the value of pi is 3.14. Now remember, if I just get the value of pi like this will give me an error because it is not on the base package of Python. So if I go this way, you see it will give me an error because it's not defined. But if I put my m.py, it's going to give me because the library is under maths. So that is it. And you can also find many other things, many things. If you just go m dot, press your tab, you are going to see all the remaining. You see them. You see I have ceiling function. Let me experiment with this ceiling function. This ceiling function simply means if I have a number like 3.11111, this should return the value 4. This is because floor function just takes the number before the decimal point, like 3.1, 3.2, 3.7, 3.9. So the floor function just takes the 3. That's the whole number before this decimal, the whole number that is just at the base of the decimals. while the ceiling function takes the upper number. So this should give me 4 because this number is between 3 and 4. So the floor function takes the 3 while the ceiling function takes the 4. Let me give an example of the floor function which we have before, but let's take it. You see that's this floor, and let's get the floor function of 3.1111. You see it will return 3 because that is the whole number that is lesser than this number, while the ceiling function is a whole number that is greater than this number. So you can also find your cosine and your sine and everything that you want to find, your tangent and exponential and everything. So let's say we want to find the sine. You can see our sine here. Let's go for the popular one we know. Let's say sine 30. Okay, so you can see the result here, sine 30. If you want to find the cosine, okay, so and so on and so forth. So these are part of the functions that are not the base functions that you can find.